Uh, Good afternoon, everyone. Today we are going to discuss memory management by operating system. How to manage the memory by operating system. Before understanding the memory management, we should know what is memory and how can store the data in a memory. So here we are going to discuss this topic for managing the memory. Memory basically a storage device where we can store the data and we can access the data as per our requirement. Okay, so first one is background. So what is program? As you know, the set of instruction is a program, and whenever we want to execute a program, first of all this program got into a memory, then we can run the program. Okay, so in form of queue, we input queue, we can run the program using operating system. Okay, so there are two kind of addresses. First one is logical address, second one is physical address. Logical address is generated by the CPU and physical address seen by the memory unit. How we can store the data in physical memory, we will explain later. Okay, so memory management unit is responsible for performing the mapping in between physical address and logical address. Okay, how we can convert, how operating system can convert logical address into physical address. So MMU, memory management unit, is responsible for doing this task. So using swapping, this task can be performed. There are two type of processes during swapping. First one is swap in, second one is swap out. Swap in means memory to hard disk, and swap out is hard disk to memory. Okay, this kind of swapping can be performed in a during mapping process. Okay, so this is a semantic view for schematic view for swapping of processes. This one is swap out and this one is swapping. Okay, next one is there are two kind of allocation of the memory. First one is contiguous allocation, second one is non-contiguous allocation. During contiguous allocation, first of all we know what is the structure of memory for storing the data. There are two part of memory. First one is resident operating system area, second one is user process area. Okay, during this two part we can define the memory. Okay, so main memory usually into two partition, resident operating system and user process, then hold in high memory. So but how to allocate the memory? Whenever process is requesting for memory, so operating system analyze the all memory area on the basis of space availability. The process can occupy a memory during execution. Next one is multiple partition allocation. There is multiple, you can understand using this diagram. There are multiple processes, and we can assign the memory to multiple processes. This one is whole. Basically, this one is whole. Free space available in a memory is called whole. We have to minimize the whole for better utilization of the memory. So next one is dynamic storage allocation problem. So how we can utilize in efficient efficient way to any memory. There are three kind of problems. First one is first fit, second one is best fit, and third one is worst fit. In this particular allocation, allocate the first hole that is big enough, and best fit allocate the smallest hole that is big enough, or in worst fit allocate largest hole, must also search entire list, produce the largest leftover hole. Okay, so this kind of allocation take place for any requesting process. Next one is fragmentation. There are two kind of fragmentation: external fragmentation and internal fragmentation. External fragmentation, total memory space exists to satisfy a request, but it is not contiguous. And internal fragmentation, allocate memory may be slightly larger than requested memory. This size difference is memory internal to a partition but not being used. This is a problem. This problem is solved by the compaction, and this problem is solved by the paging and segmentation. Okay, so what is compaction? Reduce external fragmentation by compaction, shuffle memory content to place all free memory together in one large block. Where compaction is possible only if relocation is dynamic and is done by the execution time. Okay, so we can suppress the all free block using compaction mechanism. Next one is paging. We can represent the memory in form of pages. Okay, each page have its fixed size. Okay, on the basis of pages we can divide the overall memory. So these are main criteria for defining the pages. Keep track of all free frames. What is frames? Frame we can space available in the main memory is called frame. Or page is logical, means divide logical memory into blocks of same size is called pages. So there we can define the page table using page number and page offset. This is logical address and this one is physical address. Using this diagram we can understand our own architecture, address translation architecture. CPU is generated logical address and this one is page number, this one is offset. Using this page number we can